For decades, experts believed a factory capable of practically building and optimizing itself was still pure science fiction, something that belonged in movies, not on an actual production line in the middle of Texas or Nevada. Today, some of the biggest names in industrial engineering are no longer so sure, and that shift in confidence did not happen because someone found a shortcut. It happened because the technology finally caught up to the dream. So let's start with the obvious question. Why did nobody believe this was possible in the first place? For years, the consensus among manufacturing experts was that a fully autonomous factory was decades away. Not because the idea itself was crazy, but because manufacturing is messy in ways that software alone simply cannot fix. Real factories deal with variable parts, unpredictable exceptions, human safety concerns, volatile supply chains, constant maintenance issues, and machines that need real dexterity to handle objects that do not always behave the way engineers expect. Even Tesla, a company obsessed with automation, learned this the hard way. During what became known as its production hell years, Elon Musk himself admitted that in many cases, human workers were simply better than robots at certain tasks. That was not a small confession. That was one of the most automation-obsessed companies on the planet publicly saying that machines were not ready yet. So if that was true just a few years ago, what actually changed? The honest answer is that factories themselves did not become simpler. The tools used to build and manage them became dramatically more powerful. Over roughly the last 5 years, an entire new stack of technology emerged. One built around artificial intelligence, computer vision, warehouse robotics, autonomous mobile transport, and something that sounds almost like a video game but is quietly transforming heavy industry: the digital twin. A digital twin is essentially a virtual copy of a real factory, a real machine, or even an entire production line. Companies like Siemens describe this as a living model that continuously receives real operational data and feeds it back into optimization loops, allowing engineers to test changes virtually before ever touching a physical machine. NVIDIA goes even further, describing digital twin environments as training gyms for robots and industrial software agents, spaces where machines can practice, fail, and improve thousands of times over without ever risking a real production line. This is the quiet revolution nobody outside the industry is talking about. Before you build something in steel and concrete, you now build it first in code. This is where Tesla enters the story, and this is where things start to get genuinely interesting. Tesla's public strategy increasingly frames artificial intelligence not just as a feature of its cars, but as the backbone of its entire company. On its own communications, Tesla describes itself as developing and deploying autonomy at scale, not only in vehicles, but in robots as well. That single sentence carries enormous weight because it means Tesla is no longer positioning itself purely as a car company. It is positioning itself as an artificial intelligence company that happens to build cars, robots, and eventually perhaps entire systems of production. The most visible symbol of that ambition is Optimus, Tesla's humanoid robot project. Tesla's own materials describe Optimus as a general-purpose humanoid machine, designed specifically to take on tasks that are dangerous, repetitive, or simply boring for human workers. On paper, this is exactly the kind of labor that has historically slowed down full automation, tasks too irregular for a fixed robotic arm, but potentially manageable for a machine with human-like movement and adaptability. But here is where the investigation has to slow down, because this is exactly the point where hype and reality tend to blur together. Reporting from Reuters indicates that Optimus production has already been affected by export restrictions on rare earth materials coming out of China, a reminder that even the most advanced robotics program in the world still depends on very physical, very vulnerable global supply chains. Musk has stated that Tesla hopes to produce thousands of Optimus units this year, a statement that reveals genuine ambition but also real fragility, since hoping to produce something and having already produced it at scale are two very different things. Reuters also reported something that deserves particular attention: Musk's own admission that early production of both Optimus and Tesla's Cybercab robotaxi would be, in his words, agonizingly slow before eventually ramping up. Think about that phrase for a moment. That is not the language of a company describing a triumphant, fully operational robotic workforce. That is the language of a company still in the early, painful stages of scaling something extremely difficult. So when you hear claims that Tesla already has robots quietly running its factories behind the scenes, the verified evidence simply does not support that narrative yet. Now, Optimus is only one piece of a much larger puzzle, and this is where the story becomes less about robots and more about intelligence itself. Two other names deserve close attention here: Dojo and Cortex. Dojo represents Tesla's approach to building specialized computing infrastructure designed to train massive artificial intelligence systems, particularly the kind used for vision-based learning across enormous datasets. Cortex refers to the physical infrastructure Tesla has been building specifically to support the immense computational demands of training its AI models faster and more efficiently. Together, these systems represent Tesla's attempt to build not just smarter robots, but a smarter underlying brain capable of powering everything from self-driving vehicles to future generations of Optimus. Layer on top of that, Tesla's growing use of industrial artificial intelligence for automated inspection. Instead of relying purely on human quality control teams walking a line and checking parts by eye, AI-powered vision systems can scan components at extraordinary speed, catching defects that might otherwise slip through unnoticed. Add autonomous logistics, where mobile robots handle the movement of parts and materials across a facility without needing a human to physically drive a forklift every single time. Add predictive maintenance, where sensors and machine learning models attempt to catch equipment failures before they actually happen, rather than after a costly breakdown halts production. And finally, add industrial simulation, the digital twin approach we talked about earlier, allowing entire sections of a factory to be tested and refined virtually before a single physical change is made. When you step back and look at all of these pieces together, Optimus, Dojo, Cortex, automated inspection, autonomous logistics, predictive maintenance, and digital twin simulation, you start to see something important. No single one of these technologies makes a factory self-building, but combined, they start to look like the individual organs of something much bigger: a nervous system, a set of eyes, a pair of hands, and a memory, all being developed in parallel under one company's roof. And here is the part of the story that should stop you in your tracks. Tesla is not the only company racing toward this future, and honestly, that fact alone should worry you more than if it were the only one. NVIDIA is aggressively building out its own physical AI and digital twin platforms, essentially selling the simulation infrastructure that companies across the entire manufacturing world can use to design smarter factories. Siemens, one of the oldest and most respected names in industrial engineering, is already commercializing digital twin and industrial AI tools at scale, embedding this technology into real factories today, not someday. Mercedes-Benz, a company most people associate with luxury sedans rather than robotics research, has been reported by Reuters to be trialing humanoid robots developed by Apptronik for tasks like moving components and performing quality inspections on its production lines. That trial has not yet reached large-scale deployment, but it confirms something crucial. This is not a Tesla-only fantasy. Traditional automakers are actively testing the exact same category of technology. Then there are the established robotics giants, ABB and Fanuc, companies that have quietly dominated industrial robotics for decades, long before humanoid robots became a headline-grabbing trend. These companies bring decades of proven reliability in industrial environments, something newer humanoid robotics companies are still working to demonstrate at scale. And finally, you have newer, highly funded challengers like Figure AI and Boston Dynamics, both pushing hard into humanoid robotics with their own distinct approaches to dexterity, balance, and real-world task performance. So why does this matter? Because industry leaders are not just watching Tesla because of robots that look vaguely humanoid and vaguely futuristic. They are watching because of the combination, the merging of artificial intelligence, industrial software, robotics, and manufacturing into a single connected ecosystem. Reuters has reported a clear shift in Tesla's public emphasis toward artificial intelligence and robotics as core parts of its identity, and voices like NVIDIA's Jensen Huang have repeatedly framed digital twins and what he calls physical AI as an entirely new industrial layer, one capable of compressing the time it takes to design, test, and deploy advanced automation systems. That is the real disruption story here, not a single miracle factory, but a fundamental shift in how factories everywhere might eventually be built. This naturally brings us to the open question that should stay with you throughout this entire story. Are we watching the early birth of a completely new model of manufacturing, or is this still much further from reality than the headlines suggest? Because for every promising development, there is a very real, very grounded obstacle standing in the way. Humanoid robots like Optimus still face serious limitations in dexterity, the fine, adaptable hand and finger movement required to reliably handle unpredictable objects the way a human worker computer instinctively can. Reliability remains an open challenge as well, since a robot that works perfectly in a controlled demonstration is very different from one that can operate flawlessly, day after day, inside the chaos of a real high-pressure production environment. Maintenance adds another layer of complexity because every additional robot introduces new components that can fail, new parts that need replacing, and new expertise required to keep everything running. Safety certification is another massive hurdle, particularly when humanoid robots are meant to work directly alongside human employees rather than behind protective cages. And then there is simply cost and scalability, the brutally practical question of whether it is actually cheaper, safer, and more efficient to deploy thousands of humanoid robots across multiple facilities compared to more traditional automation methods that have already been refined and proven over decades. These are not small footnotes. These are the exact same physical and economic barriers that made experts skeptical of self-building factories in the first place. It is important, at this point in the investigation, to be extremely precise about what is verified fact, what is industry consensus, what comes from independent analysis, and what is simply a projection from Tesla or from Elon Musk personally. It is a verified fact that Tesla ties its long-term strategy directly to autonomy across vehicles and robotics. It is a verified fact that Optimus production has faced real supply chain pressure due to rare earth export restrictions. It is a verified fact that Reuters reported Musk's own description of early production as agonizingly slow. It is industry consensus, supported by companies like Siemens and NVIDIA, that digital twin technology and industrial AI are rapidly transforming how factories are designed and optimized. And it remains a projection, not a fact, that Tesla will produce thousands of Optimus units this year, or that any factory today is capable of expanding, redesigning, and commissioning itself with minimal human oversight. Projections describe a possible future. Facts describe what has actually happened. Confusing the two is exactly how misinformation spreads in this industry. So where does that leave us? Based on everything currently verified, the honest, unglamorous truth is this: Tesla has not created a factory that builds and expands itself without human engineers involved. That version of the story, the one implied by viral headlines, simply is not supported by the evidence available today. But here is the twist, and it is the reason this story deserves your attention instead of your dismissal. Tesla may very well be the company standing closest to making that concept a reality, not because of any single robot or any single breakthrough, but because it is one of the very few companies on Earth simultaneously developing humanoid robotics, industrial artificial intelligence, massive scale computing infrastructure, automated inspection, autonomous logistics, predictive maintenance, and digital twin simulation, all under one roof, all pointed in the same direction. More important than whether one specific factory becomes self-building is the fact that all the individual pieces of this puzzle already exist somewhere in the world today. Some pieces live inside Tesla, some live inside NVIDIA's simulation platforms, some live inside Siemens industrial software, some are being tested right now on a Mercedes-Benz production line using robots built by Apptronik. And that, more than any single dramatic announcement, is exactly what has the entire manufacturing industry watching so closely. The real revolution here did not happen overnight, and it did not happen inside a single dramatic keynote presentation. It has been happening quietly, piece by piece, supply chain constraint by supply chain constraint, simulation cycle by simulation cycle for years. And if that trajectory continues, the factories of the next decade may not resemble anything we currently think of as a traditional production line. So here's the real question worth sitting with. If artificial intelligence, robotics, and industrial simulation continue converging at this pace, how long until the phrase self-building factory stops sounding like science fiction and starts sounding like just another Tuesday in Texas or Berlin? Let us know what you think in the comments below. And if this kind of deep, verified investigation into where the auto industry is really heading is something you value, make sure you are not caught off guard by what comes next in this space. Join us here on Driven to Distraction, because the next chapter of this story is already being written, quietly, inside factories most people have not even started paying attention to yet.